Hello everyone and welcome to the very much overdue episode 9 since episode 8 fails to save. So let's start with a little overview about where did we get. As you can see in episode 8 I added the flowers, and you can come and by hitting G you can pick up the flower. One problem is first that flowers are presented as entities on top of the main tile map, and they are not removed when you pick them up. So once you pick up a flower, you can keep hitting G and the flower stays there. When we fix that first thing, that the flower is removed, the second problem is going to be that once you remove it, you're not going to be able to pick up anything, but it's still going to look like a flower. And the reason why is because the tile map generated as just a single layer, and even if we remove the entity, the tile underneath still looks like the flower. So the second bug we're going to fix, we're going to try to make sure that when you pick up the entity, we change how it looks underneath. Ideally, we wouldn't do it that way. We would generate tile map in multiple layers, but I think it's important to actually get something done, and we can fix the issues later on, right? So we're at the pickup, and I do remember already doing something like that, but I don't know why did I disable it. In any case, that's what needs to happen. We need to link these two lenses together, and I think I can do it just like that. Now let's just get rid of all the trailing spaces. Boom. Okay. That makes sense because we don't have a value we're going to replace the object with, but we just want to remove it. So it's not really replace object, it's more delete. So we want to delete. We don't need the replacement now. Entity from list, and I'm pretty sure there's already a list function that does that. Delete. Yeah, okay. And if entity is, I hope it's, yeah, it's deriving equals. So yeah, I don't even know why I'm bothering. Delete. Delete object. The list is going to come from items. Let's see what happens. Okay, how about this? 1, 2. Apply OG to that. And obviously this is ugly, but we'll prettify it in a moment. 188. Where is a mismatch bracket? Okay, 776. Sure. Okay, that's because wherever it's used, it doesn't have that context, I'm assuming. Correct, it's just showable, but not. It can't equate. Oh. Okay, let's see if that works. Yeah, I'm hitting G and it's not going to pick it up. But as you can see, it still remains underneath. But that's the second bug we need to fix. So what we're going to do, let's first make this a bit better. As you can see, this pattern of function where you take some parameters and then the last two are basically the same because you're expecting the function to modify the value of this type. This is just state monad. And one easy way to take function like this and run it through a state monad is to just use the state function. But what I want to do here, instead of having this ugly stretch, I'm gonna run state monad here. So, well, not run it, I'm gonna exec. There's three different functions, right? You have run, evaluate, and execute. Run is gonna return you a tuple of the value that you calculate from the state monad and the last state. Eval state is just gonna return the value and discard the last state. But what I don't care about the value because it's a tuple, I think, and I just want the last state. So I'm gonna flip. First of all, let's import control monad state, and then if you check exec state, see, take some state monads, take first state value, and you get out state value. What I want is to first pass the state monad code last, so I'm flipping the exec state and I'm passing my sourcing state first, right? Maybe we can do it like this so that it's a bit clearer. And then we execute do, and we have our nice piece of code here. Now the second issue is that these operators work like functions. If you check, see, they don't work with state monad, and I could very simply just use, again, from state monad, control monad state, it's called state. As you can see, this pattern is going to match very nicely with this, but I'm not going to do that. You already have functions inside control lens that do that, and for any import control lens, please. Yes, for every function, for every operator, you're going to have a version that instead of using this operator, which creates a pattern to use with functions, you have an equality operator. You know, you have this kind of operator, which means just set the value from the right side, and you have this which works on a state monad. So we run states, we do modifications with it, and that should be a tiny bit clearer than the beginning. Yes. check it out. Well, still the same, right? Just a bit tiny cleaner. And then you could go a bit further than that, and you could modify this whole function to actually work with the state, but that's for later. The thing number 3, we said we want to modify the underlying tile map. So if we look at the game, data game, thank you. We have our tile map, and then we have items that are drawn on top of it. And the tile map that's generated, it's already generated to include flowers. So what we need to do, until we build a better generator, we need to make sure that the tile map, so right here, map, we shall change the tile at this specific location, which we have as, I'm pointing at the screen as if you can see. We have this here, we're gonna change this location to include a grass, right? Because when you pick up a flower or a rock, which we can also pick, what should be there is grass. And I guess this is where I can use the replace, and that's why I made it before. Replace object. Entity A, no, but that's not what I want to do. This is wrong. What I want to do is take tilemap D, and let's see what tilemap, how are we running our update. It's called here, game loop. That's what I need. I'm gonna put it here on the side. So tilemap runs tile with cursors drawable, and cursors drawable everywhere, right? And everything else is just remaining as open as it can, which is a good practice. So our replace object, we need to know it's cursors drawable, and that's propagate upwards, but that's totally all right. Maybe not, we can do something else. So we want to replace object at this position with an object. And I want to take a tile map of type D and return a tile map that carries type D. That should be fine, right? So we have a vector, we have a replacement value, and we have a tile map. And then we can express this nicely with the lens and probably in line. We want tile map. Right, we want map data. So map data replace and replace yeah, we don't want to replace the whole array with the whole vector. We just want to replace it one specific position. And I think there already is a len that does that, but I'm not entirely sure how it works, and I don't want to spend time looking it up now, so I'm just going to do it with a vector. Import data vector. And I think there's the operator, something like that. Yeah. I mean, this one is for list, but if I do data vector, yeah, no. This is pooling. Oh, this is probably going to be super slow, but you know what? It's going to work for now. So map data, and then we take map data on one side vector operator, so this operator, and we want to replace the value of v with replacement value. Does this make sense? Sure it does. But then I assume we can just inline that map data. Now let's see if we can flip the operator. Data vector replace. Nope. That's fine. It can stay like this for a bit. Or you know what? As I said, it's been a while. Okay. Again, where am I missing these brackets? I do have imported data vector, sure, and I need this operator. Variable not in scope, no problem. So I can either change this type, but what I want to do, it kind of makes sense that when you pick up an item, you want to pass in a replacement item for the ground, at least at this point in time. So we're gonna do that. We're gonna push it from upwards. And then once we're at update, this seems like a good context where we can summon this replacement diamond. So we're gonna say replacement tile. And the replacement tile, let's make it into a function. By a function, I actually mean. So now we need curses drawable. I meant a constant, not a thing. And curses drawable is character and its attributes. Sure. So let's so if I get drawable from tile, right, I can just ask a grass tile. Drawable from tile and tile grass, and this is what happens when you tie your data with your presentation. Now I have to know what it is, and that's another thing we need to fix because this is bad, but let's leave it for now. Bon. Okay, that makes sense because we need to replace an index, and we do have a function for that. Coordinates to linear, it takes vector and it takes width, and we get width from OG map width. So there's this thing that I remember I used word because I did not want my type to go into negative, but it doesn't really solve the problem. And the reason why it doesn't solve the problem is because if with integer, whatever will become a negative value, here you're just gonna flip over and end up with a value that's like up in billions. And this is now creating issues. But you know what? let's just do this for now, get it to work, and make it work better later. Okay. Match type D with B. That's because you don't know that they're the same, but they are. And we can express the equality by doing this. This is a type equality operator, and you can express it as a type constraint. It says the types B and D could be the same. Obviously, you could just go and replace D everywhere you see it with B, but I'm being fancy. Sure. Type families. Not that I don't like GDTAs, but gadgets. Oops. So I don't really need this at all. I just being dumb. Okay. It's tile D. Right, and here he's having the problem because he doesn't, so we're trying to use curse as drawable here, but he doesn't really allow us because the type here is D and B, right? So we have to push this equality forward. So types B and D are unequal, and B is equal to curse as drawable. Again, you don't have to do that. It would probably be cleaner that I just change the types, and that's what I'm gonna do. I just want to make sure it works. Where now? 49, no, 152, 49. This should work. What's the problem? Right, it's not a tile. No, it's a tile. Where is my tile constructor? This is simple enough that it doesn't warrant another identifier. One thing which I keep stressing as much as I can to my clients and employments is that do not introduce identifiers unless you have to. Like, use type classes, use overloading. And it doesn't work just for Haskell, it works for any language. Every time you introduce an identifier, you're forcing your teammates to memorize this identifier. And sure, it might be super clear to you and you know exactly what you meant, but they're just gonna have to learn what these things are. And if you use overloads instead, what? No, that was a mistake on my side. If you use overloads, they don't have to, because white space at the end, yes, sorry, or white space next to the end. That's better. I wanted to remove trailing spaces. Yes, if you use overloads and you don't introduce identifier names, like, they're gonna use what they already know. You know, it's one good example was exactly right here. Why do I need to put replacement tile? Sure, it makes sense as a keyword, so they would assume, oh, okay, so that's what it is. But right here, they immediately see, okay, so he's using a constructor because it's a capital letter, and then he's introducing some kind of a tuple here. Ideally, this tuple would actually be a new type, but you know, I find this much easier to process. You don't have to jump around the code and read. Anyway, back to the thing. So pick up the position, replacement. It doesn't actually need a replacement tile. It just needs a replacement drawable, right? Yes. And then right here, 152.49. Oh, I understand. Okay. Here, the D is specialized into the tile, and right here it's not. So what, and that's why it makes no sense. We do want to make sure that this is a tile. Give me 1 second. All right, let's see how this works. That's all right. This contains tiles, and you don't want a B here. You want a tile replacement, no? Yeah, you do. Sure, and then right up there, it does actually have to be a tile. Well, main, let's see if that works. Flower, yeah. Well, it's an ugly grass, but we know it works. And should be working for rocks too. So, what we want to do now, we would want to separate the presentation of the tiles, which is now kept in the data, well, from the data. And that way, we can create sets of, for example, the grass tile would have a set of possible attributes, how to draw it and all that. I don't know how much time am I working on this, but I guess we could stop. It's been 28 minutes. You know what? I think for this episode this is enough. And next time, hopefully less than 7 days, we can go and fix that too. I'm gonna commit all the code, and for all of you that's been asking me to continue doing this, I'm just gonna say I'm sorry that it took so long, but as I said somewhere before, life happened. See you soon.